Hi, welcome back to College Algebra. Today we're looking at section 3.7, rational functions. So a rational function is any function that is just two polynomials, one in the numerator and one in the denominator. So you'll see here I have an example, f of x is 3x squared plus 1 all over x cubed plus 3x minus 5. And so this is the kind of function we're going to explore here in this section. The first thing we need to look at is the domain for these. Turns out anything will work. So you can use all real numbers unless it makes the denominator equal to 0. Okay, because if the denominator is equal to 0, you're going to be dividing by 0, and we can't do that. That doesn't make any sense. So tied in with the idea with the domain is this concept we're going to have of a vertical asymptote. So you can see I have a graph here, has a dotted line down it. That's my vertical asymptote for this graph. And what I want to say about it is that you can't cross a vertical asymptote. The whole point is that's an x value that blows up the function, right? That makes the denominator equal to 0. So you can't actually cross over that line. And they happen anywhere that the denominator is equal to 0, as long as your fraction is reduced. Okay, so we'll look at one later where we can reduce it first, and we'll see what happens. But as long as your fraction is already reduced, which is most of the time, they happen wherever the denominator is equal to 0. So let's look at an example and find some vertical asymptotes and see what happens with these vertical asymptotes too. All right, let me get some new stuff. All right, so I have a little bit more information about vertical asymptotes, and we'll save an example with vertical asymptotes for later maybe, because they're kind of straightforward. But here's what we want to look at here. I have what happens if at a vertical asymptote. So my function is something over x minus a to the n power. So what I know is that a is going to be a vertical asymptote, x equals a, that's the line. Because if I take x minus a and set it equal to 0, I get a. Now, what happens at the asymptote is going to depend on that power, the multiplicity, if you will, of the 0 in the denominator. If n is odd, so if this n were a 1 or a 3 or 13, it's going to look like this. It'll go up on one side of your asymptote and down on the other. Now, which side is which? That's going to be something we'll have to figure out in each specific example, but they have to go opposite directions. Up on one side, down on the other. If n is even, they're both going to go the same way. So in this case, I drew them both going up, but they just as easily could both be going down. Okay, odd, different directions, even, same direction. All right, let's move on. All right, the next thing we want to talk about here with our rational functions is something called a horizontal asymptote. A horizontal asymptote is really the end behavior for our rational function. So we're looking at what happens as you go really far out to the left and the right. Now what's going to happen for most of these is that they are going to level out along a line y equal to something. Okay, so you can see that I have a dotted line here. I have a graph. It's doing something weird in the middle, who knows what. But on the ends, it's leveling out right along that dotted line. That's my horizontal asymptote. So the question is, how do we find a horizontal asymptote? And that's what I have over here on the board. So pretend that we have a function, f of x is equal to a sub n x to the n plus a lot of other stuff, all over b sub m x to the m plus a lot of stuff, right? We have polynomials. The reason I didn't include all that other stuff is because the only part of this that matters is the first term for the top and the bottom. Okay, so what we're going to do is we're going to compare the powers on the top and the bottom, because bigger powers grow faster than smaller powers. So if the bottom has a bigger power, okay, so if my m here on the bottom is bigger than my power on the top of the n, it's always going to be y equals 0 because you're dividing by something that's growing faster than the top, and that's going to squish it down and make it all go to 0. If the two powers are even, well, again, since these first terms are the only thing that matter, what would you do if you had x to the third and x to the third? You would probably just cancel them out. And what would be left would be those coefficients, a sub n over b sub m. And that's the line that would be our horizontal asymptote. The third possibility is that the top has a bigger power than the bottom, in which case you do not have a horizontal asymptote. Now we will look at an example here in a little bit where we have what's called a slant asymptote. And that happens when the power on top is exactly 1 bigger. And as it sounds like, a slant asymptote is not going to be a horizontal line, it's going to be a slanted line. But we'll see that in a little bit. So anyway, those are horizontal asymptotes. So now I want to jump in and do some examples, not just with horizontal asymptotes. I actually want to make some graphs. So I'll give you some steps, and then we'll try and look at some examples and see what happens. All right, so now I have the steps for graphing, and I have an example which is going to take us through all of these different things that we've been talking about, and then hopefully we'll have time, and we'll do some more examples. All right, so for graphing, we need a y-intercept. Remember, to find a y-intercept, you plug in 0 for x. We need the x-intercepts, if possible. They don't always exist for these functions. So if you get into it and you're like, I don't see any x-intercepts, then okay, then there aren't any. You get to skip that. 3, we need horizontal asymptotes. 4, vertical asymptotes. And step 5 is extra points. Okay, so there we go. Now, what are extra points? Those are you saying, you know what? I have everything you told me I needed to have. I still don't know what this looks like. Let me throw some extra x values into the function, see what comes out, and see if I can figure out what this graph looks like. All right, so I have f of x is equal to 2x squared minus 18 all over x squared minus 4. The first thing I did was I factored it. Okay, if you factor out the 2 on the top, you have a difference of squares, so you get x plus 3 times x minus 3, and on the bottom, it's already a difference of squares, so we get x plus 2 times x minus 2. The factored form is going to be useful, and we'll see that here in just a second. So then I'm going to run through my list. Step 1, I plug in 0. If I do, I'm going to use the original form because that just makes those x terms drop out. We get negative 18 over negative 4, which is 4.5. So that's my y-intercept. And so you'll notice I put a point over here at 4.5 on the y-axis. Step 2, I want those x-intercepts if I can find them. Turns out that to find x-intercepts, we only have to worry about the numerator. The denominator is going to supply our vertical asymptotes. The numerator will supply the zeros of the function. So I just take the factors on the numerator that I have, since I already factored it, and I set them equal to 0. If you don't have it factored, this would be a great time to do that. Or you could throw it into the quadratic formula if it's a quadratic, or really unlucky and it's got a bigger power, you have to go through all this work we did with polynomials. Anyway, when I solve those, I get x is negative 3 and x is positive 3, and you can see I put those points on. Now, one important thing to consider here is both of those were powers of 1, which means that they each have multiplicity 1, which means that when we get to those points, we are going to cross through the x-axis. Just like with polynomials when we were graphing those, odd multiplicities will still cross the x-axis. Even multiplicities would just touch it. Step 3, we need a horizontal asymptote. So what I noticed back here at the beginning is that they both have x squareds. And so I go to that list of things that I gave you for horizontal asymptotes just a minute ago, and I say, okay, that means that my horizontal asymptote is just 2 over 1. Remember, there's a 1 there, which is 2. And so you'll see I put a dotted line here at y equals 2. For the vertical asymptote, now I need the zeros of the denominator. So I take x plus 2 and x minus 2. I set those equal to 0, which gives us negative 2 and positive 2. And again, you'll see my vertical asymptotes there at negative and positive 2 for x. All right, so you'll notice I didn't quite finish this graph because I really wanted to kind of talk my way through this a little bit with you. It's not that bad. It really isn't. So here's what I see. I know that out to the left, I'm going to start along this dotted line because that's my end behavior. Out to the left, it's going to be along that dotted line. From there, it has to hit this x-intercept and pass through the x-axis because, again, we said that the multiplicity there for that 0 was just 1. Well, at this point, it's either got to go down the vertical asymptote or up. It can't go up. The reason is, if it were to turn around and try and go up, it would have to cross the x-axis again. We don't have an x-intercept in this little teeny space here. So since it doesn't have an x-intercept, it has to continue just going down. And there's my left-hand side of the graph. So now I'm going to examine what happens at this vertical asymptote at negative 2. X was negative 2, that came out of x plus 2. But again, its multiplicity, the power on that set of parentheses was a 1. That's odd, and if you remember what we talked about a few minutes ago with vertical asymptotes, that means it's going to be down on one side and up on the other. So I know that on the right-hand side of this vertical asymptote, it has to be up. And here's what it's going to do. It's going to come down, it's going to hit that y-intercept, and it's going to have to turn around and go back up because, again, there aren't any x-intercepts here in the middle. Really, the lack of x-intercepts is something to really pay attention to because it's going to tell you which direction your graph has to go. If you don't have an x-intercept, you can't cross the x-axis. Our next intercept is on the other side of that asymptote, so we couldn't cross the x-axis in the middle. Again, this asymptote had a multiplicity of 1, so that means since it was up on the left-hand side, it's going to have to be down on the right, and it's going to just kind of go like that. It's going to come up, hit my x-axis, and follow the end behavior out. And there you go. There's an example. Let's do one more. Okay, so now I have kind of a funky little example. It's certainly going to have some interesting aspects to it. F of x is equal to x squared plus 10 all over 2x. First of all, y-intercept. There isn't one. If you plug in 0 to try and find a y-intercept, what happens? The bottom is going to blow it up. You can't divide by 0, so there is no y-intercept. Okay, that's great. X-intercepts. Now we take the numerator again. We set it equal to 0, but here, the easiest way to solve this is to subtract the 10 and get x squared equals negative 10. But then when you take the square root, you get plus or minus I times the square root of 10. We can't put I on a graph, at least not the way we're doing things. So again, we don't have any x-intercepts. So far we have no points. No y-intercept, no x-intercepts. I got a whole lot of nothing. Let's see what else I can get out of this. All right. Do we have a horizontal asymptote? Well, the top now has a bigger power than the bottom. By what I gave you for horizontal asymptotes, we don't have a horizontal asymptote. But because the top has power that's 1 bigger, we're going to get what's called a slant asymptote. All right, so here's how you find a slant asymptote. You do the division. Yay, I can tell you're excited. I know everybody loves dividing polynomials. So I did the division here. The only part that really gave me anything was the x squared divided by 2x. Gave me a half x. Everything else turned into 0. So I just got 1 half x equals 0. And that is actually the equation for my slant asymptote. So hopefully you remember how to graph a line. I noticed that the y-intercept is 0, so I have, for my slant asymptote, I have a point at the origin. The slope is 1 half, so I go up 1 over 2. That gets me a second point. And when I connect that, I'm using a dotted line because this is an asymptote. I have my asymptote. So that's all we do. We divide the polynomials out, and we don't care about the remainder. The remainder doesn't count. We just do the division, throw away the remainder. That's why I just had 1 half x. All right. So there we go. And vertical asymptote. We steal the denominator. 2x is equal to 0. That gives us x equals 0. So you'll notice, hopefully, you can see it that I have some dotted lines sticking out of my y-axis because I have a vertical asymptote of the y-axis to go with this slant asymptote. All right, no points. Yay. Now the good news is I'm not too picky. I just need some rough sketches. But this might bother some of you. I can make this graph and I'll show you why. It's really not bad. But I understand if you're like, but there's nothing there. I get that. But here's the really important bit. There is nothing here, including there aren't any x-intercepts, which means it is impossible for this graph to ever cross the x-axis. So when I look at this, because I'm just looking for a pretty rough sketch, I notice, okay, here's my end behavior, right? My slant asymptote will be the end behavior of this polynomial. So it's got, rational function. So it's got to come in along this dotted line. But since it can't cross the x-axis, and then we have a vertical asymptote here at the y-axis, it's just going to kind of turn the corner and go down. It can't go up because if it went up, it would cross the x-axis. This vertical asymptote, the x had a power of 1, right? It came out of this 2x, which has a power of 1, which means if it's down on the left, it has to be up on the right. So it's going to come down along there. And again, just like before, it can't cross the x-axis, and it's got to follow the dotted line out to the right. So this is my graph, and this would be quite sufficient. So good luck with these, and yeah, have fun.